Hello and welcome to today's lesson on elastic potential energy stores, which is part of the energy topic in GCSE Separate Science and GCSE Combined Science Physics. So in today's lesson we're going to look at how you calculate the elastic potential energy stored in an object. So if we've been successful and learned in today's lesson, we should be able to define what elastic potential energy is, then identify and describe elastic potential energy stores, and then finally calculate the elastic potential energy stored in an object, which forms part of the AQA GCSE Physics specification, which is elastic potential energy. Now, as mentioned previously, there are many different energy stores in the universe. Energy can be stored in many different ways, from the thermal energy store to the kinetic energy store to the chemical energy store to the electrostatic energy store to the nuclear energy store to the gravitational potential energy store to the magnetic energy store, and finally the elastic potential energy store. Now, in this particular lesson, we're going to consider the following energy stores: the kinetic energy store, the energy due to movement; the gravitational potential energy store, the energy due to position; the thermal energy store, the energy due to heat; and the elastic potential energy store, the energy due to an elastic object stretching. Now, we're going to consider these stores as we can be able to calculate the energy that's found in these stores. Now, we've already looked at equations needed to calculate these top three stores. So we can work out the energy in the kinetic energy store by doing the equation kinetic energy store is equal to 1/2 times by mass times by velocity squared. We can work out the gravitational potential energy store by doing the equation the gravitational potential energy store is equal to m mass times by the gravity times by the change in height. And we can work out the energy in the thermal energy store by carrying out the equation the thermal energy store is equal to the mass times by the specific heat capacity times by the change in temperature. But in today's lesson we're going to look at how to calculate the elastic energy stored in an object. Now, the elastic energy store is the energy stored in an elastic object due to being stretched by a force. Now, the scientific term for stretching is in fact extension. Now, a force that causes extension is called tension, or the tensile force. So when you have an object which has a tension acting upon it to cause extension, it becomes an elastic potential energy store. Now, the elastic potential energy store can be calculated with the following equation: the elastic potential energy stored is equal to 1/2 times by the spring constant times by the extension squared. Now, it's important to note elastic potential energy is measured in joules, spring constant is measured in newtons per meter, and extension squared is measured in meters. Now, it's important to note that the spring constant is how much tension, how much stretching force is needed to extend a material by 1 meter. The extension is how much the material has stretched with the force compared to when there's no force on the material. Now, it's important to note that the extension can be worked out by looking at the length of material without a tension force placed on it, such as 8 centimeters. Okay, you then measure the length of the material with a tensile force acting on it, so the stretched length could be 11 centimeters, and the extension is the difference between the stretched length and the unstretched length. So we can say extension is equal to stretched length minus original length. So therefore the extension in this example is 11 minus 8, which is 3 centimeters, which we would then convert to meters to use in our equation. So like we said before, the elastic potential energy stored is equal to 1/2 times by spring constant times by extension squared. Now, we can use this to calculate the work done in extending an elastic object. So just to clarify, like we said before, spring constant is how much force is needed to extend a material by 1 meter, and the extension is how much the material is stretched with the force compared to when there's no force on the material. So it equals the stretched length minus the original length. So it's important that we are aware of that. But also note that only elastic objects can be potential energy stores. So in this example, which objects are elastic and which objects are inelastic? Well, a rubber band is an elastic object whilst blue tack is an inelastic object. Now this allows us to come up with definitions for elastic and inelastic objects. An elastic object is an object that returns to its original shape when the tension force the object causing it to stretch is removed. So for example, you can place a tension force on the rubber band, and then you can then release that force and it will go back to its original shape. Whilst an inelastic object is an object which stays stretched when the tension force on it is removed. So for example, with blue tack you can stretch out this object, and when you remove that stretching force, you remove that tension, the blue tack stays stretched. So let's just look at how we use this formula. So elastic potential energy stored is equal to a half times by spring constant times by extension squared. So if the spring constant was 2 newtons per meter and the spring is extended by 0.3 meters, then the elastic potential energy is equal to a half times by 2 times by 0.3 squared, which when we put into our calculator is 0.09 joules. Now please remember to give your answer to the correct number significant figures and give your answers with the correct units. So it's important to note that this will calculate the work done in stretching an elastic object. So the work done in extending this spring will be 0.09 joules. So what have we learned in today's lesson? That the amount of elastic potential energy stored in a stretched spring can be calculated with the equation elastic potential energy is equal to a half times by spring constant times by extension squared, where we have the elastic potential energy E in joules, the spring constant K in newtons per meter, and extension E in meters as so. So if we've been successful and we've learnt in today's lesson, we should be able to define what elastic potential energy is. We should be able to identify and describe elastic potential energy stores, and finally calculate the elastic potential energy stored in an object. So I hope you've enjoyed today's lesson on elastic potential energy stores, which is part of the energy topic in GCSE Separate Science and GCSE Combined Science. Thank you very much for listening and have a lovely day.